Hello, my name is Hyunjae from Samsung SDS, which is in South Korea. I'm going to explain my paper, which is Enhancing Semantic Understanding with Self-supervised Methods for Abstractive Dialogue Summarization. Existing approaches in text summarization mainly focus on large-scale datasets like news articles. However, there's no dataset for dialogue summarization that has enough amount of size to train large size of deep neural network. To tackle this issue, we propose 4 different self-supervised methods to enhance semantic understanding for conversational text. The methods include switching utterance, switching interlocutor, inserting utterance, and masking interlocutor. After we enhance pre-trained BERT, which is well-known bidirectional text encoder with our method, we build an abstractive summarizer for dialogue summarization. And our experimental results on the SAMSum corpus, which is Abstractive Dialogue Summarization dataset, indicate a substantive improvement measured in ROUGE scores. As I said, there are 4 different self-supervised learning methods, and I will explain more details of them. First method is switching utterance. In this task, we switch some utterances dynamically at each training step with a predefined probability. The model is required to predict whether each utterance is switched or not. At the same time, we mask some interlocutor's name with another predefined probability. This optional constraint of input utterances makes the task more challenging. Through the task, the model can capture the information flows of the dialogue and produce more valuable text representation. Second method is switching interlocutor. Similar with previous task, we switch some component of dialogue, but in this task, we switch interlocutor's name instead of whole utterance. Interlocutor's name is one of the most important components for dialogue summarization. So we designed this method to train a model to focus on interlocutor's name more than other components. And also, we have another option, that is to input reference summary as well as dialogue. And next method is inserting utterance. For this task, we insert several utterances from other dialogues. Besides, we camouflage the name of interlocutor because in most cases, the name of interlocutor from other dialogues has a very distinct distribution from others. So therefore, it makes the task too easy to predict the answer. So we change properly the name of interlocutor from other dialogues. The purpose of this task is to train a model to detect incoherent information in dialogue so that the model can distinguish the salient information from trivial ones. Last one is masking interlocutor. This task is similar with masked language modeling of BERT paper, that a model needs to recover mask token from a vocabulary. On the other hand, in our work, we only masked interlocutor's name appeared in reference summary. In this task, we also input the reference summary with the utterance to help model predict the original name logically. This is our overall approach. As I explained previous slides, we conduct self-supervised method to enhancing BERT's ability to produce more valuable text representation. After that, we built a sequence-to-sequence abstractive summarizer employing enhanced BERT weight and parameters as both an encoder and decoder. And also, we share the weight of encoder and decoder so that we can reduce the size of model and overcome a shortage of amount of dataset. And this is our experimental result. All our method shows the improvement in ROUGE metrics, especially switching utterance method dramatically improved performance by up to 6.08% in average ROUGE score. In addition, we conducted ablation test and we confirmed that masking the task more challenging by removing name of interlocutor and not adding reference can lead a better performance in our experiments. Thank you for listening.